Hello everyone, my name is Masoumehsadat Hosseini. I'm a research associate at the University of Oldenburg. Today, on behalf of my co-authors, I'm excited to present our work towards a consensus gesture set, a survey of middle gestures in HCI for maximized agreement across domains. Natural input modalities such as middle gesture have become quite popular in HCI. For example, using gestures to interact with a TV or to perform secondary driving tasks in a car, and so on. However, gestures are usually designed and targeted at specific devices and domains. As you can see in this video, this can cause inconsistency between gestures in different domains. And there may be different gestures for the same task depending on the domain. As a result, if you learn a set of gestures for interaction in a specific domain, such as at the smart home, you cannot transfer your gestural interaction knowledge to other domains. Therefore, to have a successful interaction in each domain, it is necessary to discover, learn, and memorize a new set of gestures for the same tasks, which is not ideal. Therefore, having a consistent interaction, especially in middle gestures, is essential. We know that so far many works have been done in middle gestural interaction, but they mostly focus on creating new gestures in individual domains, or gesture classification schemes, or surveys that examined how middle gestures were developed and used. Except for a few studies that have investigated the consistency of gesture between different devices, there is no comprehensive study that examines whether the gesture sets that are designed for a particular domain or situation have this potential to transfer across other domains. That we considered this in our paper. Our method for considering the consistency of middle gesture is based on a systematic literature review. To this end, we systematically created a corpus of relevant papers on middle gestural interaction. From 2,057 papers that resulted from our initial search on 7 databases in the identification phase, 172 papers were relevant to our purpose, that remained for future analysis. The papers were related to different domains such as the smart home, in-vehicle and automotive, and so on. As part of our work, we classified papers into 12 different application domains based on their subject or motivating use case. We also extracted middle gesture and their corresponding comments from these papers. A total number of 1,728 gestures were extracted. Before I continue my talk, I would like to explain some of the key concepts that I'll use during my talk. The first one is referent. Referent refers to a category of terms used in interaction, such as command, task, affect, and so on. Through a bottom-up approach, we identified similar concepts among these terms and grouped them into a single category and called them referent. For example, increase was assigned as a referent for commands like increase volume, brightness up, or heater volume up. The next concept is agreement rate. This is a numerical measure quantifying the magnitude of agreement and similarity among the gestures proposed for each referent. For example, if a referent has 3 groups of identical gestures with the size of 60, 3, and 1, then based on Watavio and Wobrook's work, agreement rate is 0.64. To calculate agreement rate, we need to know when to count certain gestures as similar. For this, we use gesture theme concept. A gesture theme is a particular mental model or idea of one or more gestures. Gestures within a given theme are similar in terms of their mental model and just general idea. However, they can differ in terms of execution, body part, path direction, or flow. We refer to these different variations as gesture variant in our research paper. As an example, this figure shows some of the variations of pull or squish. We cluster the gesture using a bottom-up approach to identify their themes. In this paper, we constructed a cross-domain consensus gesture with the intention of being maximally transferable across domains. Our process for reaching this consists of 3 steps. First, we identified a referent for our consensus set. Second, we selected a gesture theme for each referent in our consensus set. And finally, we compared our cross-domain result with the result of individual domains. Our method for considering consistency is based on agreement rate calculation, but we use the literature as a base for calculating agreement rate, not end-user elicitation. Therefore, we calculated agreement rate for all referents identified in the papers, containing more than 56 referents. As you can see in this graph, agreement rate varied between 1 and 0 based on our analysis. To construct our gesture set, we selected referent with high or very high agreement rate, containing 22 referents. For each referent with high or very high agreement rate, we selected the most frequent gesture theme. For example, we found consistency for translate. For translate, swipe or slide is selected as the selected gesture theme because it was the most frequent gesture theme for this referent. It has been done in the literature with different variants, such as with finger, arm, leg, and so on. Additionally, we noted how often the referent and selected gesture theme for that referent occurred in the related work. For example, in 59 papers, gestures were introduced for translate. Among all of them, 63% are related to swipe or slide. In order to understand how our cross-domain consensus gesture set is mapped to different referents across domains, we identified the 3 most frequent gestures for each referent and determined their distribution among different domains. As an example, as you can see in this table, for the translate referent, we found that swipe was the most frequent gesture in our cross-domain consensus gesture set, and it was also the most frequent identified gesture in each individual domain, except in accessible and adaptive system, as well as in vehicle and automotive. And finally, to understand how the agreement rate of each referent varies across different domains, we calculated the agreement for each referent separately within each domain. For example, this heat map shows result of translate. Here, green values are related to very high or high agreement rate, and red values are related to low or medium agreement rate. We found that translate has a high agreement rate in cross-domain situation, as well as in manipulation navigation, large public interaction, gaming, and some other domains. In general, our analysis suggests that the selected consensus set remains more or less stable across domains, because the selected gestures in the consensus set are either the most frequent or at least the second or third most frequent gesture theme in each individual domain. And most referents with high agreement rate in cross-domain situation also have high agreement rate in individual domains. Furthermore, most referents with low agreement rate in cross-domain situation had low agreement rate in individual domains as well. Thank you very much for listening to this talk. Please get in touch with me or find our paper for more details of our work.